Alright, so we're going to just briefly review some of the topics in Chapter 1. First off, really, is the idea of functions and domain and range. So if you remember, a function is one input, one output. And then domain is our acceptable x values. And really, we're just looking at things that would lead to an error, so like division by 0, or since we're grounded in the real numbers system, taking the square root of a negative number. And then the range is the outputs that we get for those things. So it's our y values. So x values is domain, and then y values is our range. So if we have this function, I'm looking at the domain, I can plug in anything I want as long as it's not equal to 3. If I plug in 3, I will get a 0 on the denominator here, and I'll have an error. So my range, if I just look at this, I'm going to have the ability to produce any output that I want. And we'll see that we might have to adjust this as we go forward looking at the graph. But for the most part, we can put in anything. There's nothing that's going to restrict those values. As we look at our range on this given domain, if x is 5, I get y equals 2. I'm just plugging in values for here, right? So 5 minus 3 is 2. 4 over 2 gives me the 2. If x is negative 5, I plug in a negative 5. That's negative 8. 4 over negative 8 should be negative 1/2. So that's my range values given that domain, that interval of the domain. Now if I start to graph it, again, we might have to go back and look at our range here, but what we're really looking at is there's that value of x equals 3, so that's an unacceptable value, right? It becomes a vertical asymptote. And then I need a y-intercept, that's where x is 0, so I get y is negative 4/3. So again, I just get rid of that x, and I get negative 4/3. And now, if I try to get an x-intercept with y is 0, I'm going to get 0 equals 4 over x minus 3. Well, there's no way that I can make this side 0, right? I'd have to make the numerator 0, and it's just a constant of 4. So there is no y-intercept. So as I go back to my range, all right, really my range is all real numbers, right, given y not equal to 0. So I can get any output that I want except for a 0 output because of this numerator here being constant. The other major concept besides, if I need to then graph those, so this is what my graphs look like as I put those values in. And you can see that this line here, the x-axis, becomes a horizontal asymptote going across. If I want to figure out my inverses, then I switch x and y, and then I will do that here. So I take my x, y, value and swap them around, and then I solve for y. And that's pretty straightforward for this one. I would multiply by 6, I would subtract 4, that's negative y, take the opposite of all of it, and that's my inverse. And so if I'm looking at the domains and ranges, if my original has a domain and range of all real numbers, there's nothing that's going to make that blow up. Then what I'm going to do here is my inverse just swaps those. So my range becomes my domain, and my domain becomes my range from my original value. For looking at the next one, again, if it's a function, I have one input, one output, and this one is going to satisfy that requirement as I go forward. The things I'm looking for that would be problematic with this would be like a y squared value. That would be something that wouldn't work. So look at this one just to show you it's got some logarithm stuff. Again, I switch x and y, and then I solve, divide by 5. To get that exponent down, I have to take the natural logarithm of both sides. So ln of x over 5 minus 2 is y, and then go through the same thing of is it a function, is it not? And you have restrictions on the domain and range. If we look at some operations on functions, so we have at the top here compositions. So f composed of g of 3 means f of g of 3. So we plug in 3 into our function g to start with. So 3 squared minus 4, that should be 5. F of 5 becomes the square root of negative 1, which is not a real number, and so that's not a solution or acceptable in our real number system as we're doing this. If I plug in g of f of x, that just means I plug the whole function g of x into f. So I get the opposite of x squared minus 4 plus 4, and that's 8 minus x squared. And then what I need to do to figure out my domain and range is to think about what's happening here. So that is the range of g of x, which becomes the domain of f of x. So if you think of the possible outputs well, there might be a further restriction on f depending on what this looks like, but we can look at here what we got going on. So what are my outputs for g of x? Well, that's y is greater than or equal to -4, right? If I put in my minimum value of 0, my maximum value is anything bigger than -4. Anything else will become larger than -4. And so the question is that going to be acceptable in f of x? Well, let's think about it. The minimum of -4, that's going to be the square root of 8. That's acceptable. Anything larger than that is going to be acceptable to a point, right? So as soon as x is greater than 4, I have a problem. So my range here, my domain, is that's the starting point for g, but it has to be, less than or equal to 4. If I start to get a value bigger than 4, let's say that I plug in 5 in here, right? So 5, right, would be that square root of -1 just like below, which wouldn't work. So that's not acceptable, even though it would work as an output in g of x. So I could have 5 is some x squared value minus 4, right? And then we know that x is 3, and that would work there. So we got to be a little bit careful as we talk about our domains and ranges for compositions of functions. Are they inverses of each other? They're not, because they're not equal to x when I compose them. So if I want to figure out if those values are inverses, when I do the composition both ways, I should get x as my output. All right, and the last one is our starting point kind of on transformations. So if I look at where these points have moved, so I have these red points have mapped to each other, and I look at a horizontal shift to the right of 1, and a vertical shift up of 2, and then these green points tell me if there's any stretch. So if I look at this, there's going to be a stretch of 2. So instead of going over 1 and up 1, I go over 1 and up 2. So that's a factor of 2 larger as I do this. So then I need my parent function. My parent function is the absolute value of x, and then I just put in my transformation. So to move it to the right 1, I would subtract 1. To move it up 2, I add 2 outside of it, and then to stretch it, I multiply the first part by 2 as I go forward. And I could check, if I really wanted to, if I put in this case, 1, I should get out 2. And let's see if that happens. Right over here, if I put 1, that's 0. 2 times 0 is 0 plus 2. That seems to work in that case.